Hello students, in previous video of this chapter we have discussed that Maxwell predict the existence of electromagnetic waves. Although his prediction was all theoretical, there was no experimental proof of electromagnetic waves existence at that time, but he gave his theory. And the idea about the existence of electromagnetic wave he get from the Faraday's law of electromagnetic induction. But after 22 years of Maxwell's prediction of electromagnetic wave, Hertz successfully proved the existence of electromagnetic waves experimentally. So in 1865 Maxwell theoretically predict the existence of electromagnetic waves, although at that time there was no experimental proof. Then after 22 years in 1887, Hertz in his experiment proved the existence of electromagnetic wave practically, experimentally, and here we are going to study about his experiment in this video, and the experiment is known as Hertz experiment. This experiment shows the existence of electromagnetic wave experimentally. The diagram shown here is the experimental setup used by Hertz in his experiment. Basically, he worked on the fact that in an LC circuit, whenever we have a circuit containing inductor and capacitor, oscillations are present. We have already studied about LC oscillations. So whenever we have LC circuit, oscillations exist there. The charge that is present in the capacitor, it oscillates across the capacitor plates. And since the charge is oscillating, it has some acceleration. Its velocity is not uniform because it is oscillating, means oscillatory charge has some non-zero acceleration. So he conclude that since the charge is oscillating, it has non-zero acceleration, and we already know that the source of electromagnetic wave is a non-zero acceleration. So when we have accelerated charge particle, there are electromagnetic waves emitting continuously from that setup. This he had proved in the experiment. So basically this is the experimental setup, and Hertz used an oscillatory LC circuit for production of electromagnetic wave in his experiment. And the reason of using LC oscillatory circuit is because if we have oscillatory charge, there exists oscillatory charge, which means the charge particle has non-zero acceleration, means there exists some acceleration, and if there exists some acceleration, that charge particle emit electromagnetic waves. So this is how the electromagnetic waves produced in the experiment. Now let's move to the setup. Setup में क्या क्या उन्होंने use किया? So there was a transmitter. The first thing was transmitter. This transmitter consists of two large square metal plates. These are of brass. So he used a transmitter that consists of two large square metal plates, and the metal used is brass. And in his experiment, the side of length of these plate that he has taken was 40 centimeter. So ये जो side उन्होंने लिया, length लिया जो plates का, that is 40 centimeter, and these are placed in the same vertical plane. उनको हमने same vertical plane में रखा है, like one over the other, such that their centers are about 60 centimeter apart. So the sides of plate is 40 centimeter, and the gap and this gap दोनों के सेंटर्स के बीच का गैप जो है, that total distance is 60 centimeter. Now the plates, these metallic plates are then connected to two thick wires. These are the wires which has two highly polished brass spheres at their ends. These S1 and S2 are polished brass spheres at the ends of the thick wires that are connected to metal plates. Now the distance between these two spheres S1 and S2, this gap, is about 2 to 3 centimeter. And again we take two thick wires which are connected to the secondary terminals of given induction coil. Then from these thick wires we again connected to other thick wires which are connected to secondary terminal of an induction coil. Now let's see how this setup work. So whenever there is some change in the current in primary circuit, means input, this input we are controlling. So if we change the input current or the current in the primary circuit of the induction coil, then that effect directly goes to this gap, and a large potential difference is set up across S1 and S2. Suppose primary circuit में we somehow interrupt the current, हमने उसको रोकने का try किया, and because of that effect goes to this gap through these terminals connected. So this gap, across this gap a large potential difference gets set up, and because of that potential difference, these metal plates get charged. Now high potential difference that is set up in that region ionize the air in the gap. यहाँ जो potential difference set up हुआ, because of that the air in that gap get ionized, and because of that this gap becomes conducting. Because of the presence of ions, this gap get conducting, and electrons and ions that produced there oscillates back and forth. They start oscillating in forward and backward direction across the gap S1 and S2. So what are the steps? When we interrupt the current here, that effect goes to this gap, and because of that interruption high potential difference set up here, and these metallic plates get charged. Now since there is high potential difference in this region, the air present here in the gap get ionized and become conducting. This gap becomes conducting, and electrons or ions produced there starts oscillating across the gap S1 and S2. Now since oscillations are present there, so those metallic plates which get charged, जो charge हो चुके थे already because of the high potential difference, starts discharging. So an oscillatory discharge of these plates starts taking place, and because of that discharge electromagnetic waves get produced. Okay, so oscillations की वजह से इन metallic plates पर जो charge store हो गया था, that charge will start discharging, and because of the discharging process we get electromagnetic waves from that region, from this gap. Since the metal plates present here form a capacitor of low capacitance, let it be C, and these connecting wires offer a low inductance, let it be capital L, then the system generates electromagnetic wave of frequency 1 upon 2 pi root LC. Now these values are small, that means the system is generating electromagnetic wave of high frequency. Since the capacitance and inductance present in the experimental setup is small, so the electromagnetic wave that we will get will be of high frequency. After all this there is a receiver, or we can say detector, this which is detecting and receiving the electromagnetic wave. So this receiver or detector consists of almost closed circular wire. Now I am saying almost closed because it is not completely circle, completely closed नहीं है ये. So almost closed circular wire that terminates at two ends having polished brass spheres. Again, here at the detector there are small polished brass spheres at the end, and the electromagnetic waves that are being produced here in the gap are reaching the detector. So these electromagnetic waves are of high frequency because we have low values of inductance and capacitance. So these high frequency electromagnetic wave, when reached to the gap of the detector, they have sufficiently strong electric field which can set up a high potential difference across this gap. So because of this electromagnetic wave, a high potential difference gets set up across the gap S1 dash, S2 dash, and because of this high potential difference, small sparks, or we can say tiny sparks, can be experienced there. We can observe the tiny sparks across the gap, and the presence of these sparks show the existence of electromagnetic waves. So when electromagnetic wave reach the gap of the detector, it has sufficiently strong electric field that it can set up a high potential difference across S1 dash and S2 dash, and because of that potential difference we can observe small sparks there. And during the practical, if we can see that spark, can observe that spark, then it shows the existence of electromagnetic waves. So this is how Hertz explain the existence of electromagnetic waves practically. So we will sum up all these steps one by one. First of all, there is a transmitter that is formed by two metal plates, especially these are of brass and of size of length 40 centimeter, and these are placed in the same vertical plane, and distance between their centers is 60 centimeter. Then these plates are connected to two thick wires which ends at S1 and S2, and these are highly polished brass spheres. Okay, these are highly polished brass spheres. Again, the distance between these two spheres is approx 2 to 3 centimeter का gap है वहाँ पे. After that, again two thick wires are there which are connected to secondary terminal of induction coil. So two thick wires connected to secondary terminal of induction coil. I am writing it as S. So two thick wires are connected to S. This was the experimental setup. Now how it works? So when current in primary coil is interrupted, primary circuit is interrupted. Because of that interruption, a large potential difference set up across S1 and S2, means a large potential difference set up across this gap. Okay, now because of this, the metal plates get charged, जो metal plates हैं that will get charged, and a high potential difference across the gap, high potential difference that is across the gap, ionize the air present at that point. So उस gap में जो air present है उसको वो ionize कर देगा, and these ions, electrons and ions, thus produced starts oscillating, or they start to show oscillation, start oscillating. We can call it as forward and backward or back and forth. Since there is oscillation across S1, S2, so these oscillations will produce electromagnetic waves are produced. Now the metallic plates form a capacitor. Metal plates form a capacitor of low capacitance. Let it be C, and connecting wires offer low inductance. Let it be capital L. Then the frequency of electromagnetic waves produced will be nu is equal to 1 upon 2 pi root LC. This frequency will be high. Since value of L and C is small, so the frequency with which electromagnetic waves are produced is high. Now after this there is a receiver, or we can call it as detector, and it is made up of almost closed circular wire, and it also has S1 dash, S2 dash, two brass spheres at ends. Now these spheres are small comparative to S1 and S2. These are small spheres, S1 dash and S2 dash. So since high frequency EM wave is approaching the detector, so the gap between S1 dash and S2 dash is small, and when electromagnetic wave reach the gap S1 dash, S2 dash, these wave have, or they have sufficiently high energy to ionize that gap, or to set up a high potential difference across it, and because of that high potential difference across the gap S1 dash, S2 dash, an observable spark exist. Although this spark will be tiny, but it will be observable, and by observing it we can conclude that electromagnetic wave exist. So this is the whole experiment that Hertz performed to show the electromagnetic waves experimentally. In his experiment, Hertz demonstrate the existence of electromagnetic wave experimentally, but it's not all. He actually demonstrated various properties of electromagnetic waves also. So the properties that was demonstrated by Hertz during his experiment, we are going to discuss that. These properties are: first, he observed that electromagnetic waves are transverse in nature. Second, he observed that electromagnetic waves, or the radiations, at the time it was still doubtful whether they are particle nature or wave nature. So he, during his experiment, observed that these electromagnetic radiations for which he was working has wave nature. He also found that these electromagnetic waves can be polarized. And the last one is these electromagnetic waves travel with the same speed as of light, means 3 into 10 to the power 8 meter per second. So Hertz during his experiment, along with the existence of electromagnetic wave, he also showed the following properties: that electromagnetic waves are transverse in nature, these radiations have wave nature, and these waves can be polarized, as well as they travel with the speed of light. So that was all about the Hertz experiment. For further videos, stay tuned and keep studying. Thank you.